Good evening, everybody.
Good evening, John.
Welcome to our spring 2017 TWed Lightning Talks. This is our anxiously awaited, anxiously anticipated event where we get to hear what everybody is working on. The way the Tetherless World works, sometimes we don't see each other until we have these events. Sometimes we see each other every day. We started Lightning Talks a few years ago now as a way to, at the end of each term, just share very quickly in sort of that elevator pitch kind of mode. And the idea is very simple. Just get up here, 2 minutes, talk about something that you want to talk about. Usually you're talking about your research, introduce yourself, who are you, and then talk about your work or talk about whatever you want to talk about. And keep in mind that we are streaming this, recording this. A couple other notes. Dr. Handler sends his apologies. Right now he's in a fireside chat with Selmer talking about the future of AI and this and that. And he sends his apologies. He's a very busy person, but he always looks forward to trying to make this meeting so he gets to hear what's going on. And sometimes we even lure him into doing a lightning talk. So very simply, when it's your turn, come up, give your spiel, and cross out your name when you finish. All right? And we should, with this number of people, we'll probably finish in less than an hour. So did you want to say something very quickly?
Yeah. So I'm Jim. Actually, there's one thing that I saw today at lunch where I didn't eat pizza, I had something else. But there's a really great speaker who talked about research and research questions. And one of his advisors had actually said that you should phrase, when you think about your research, you should phrase it in terms of a single question. I'm not saying that you change your talks today. If you don't do that if you don't want to. But if you think of a single question that you can phrase your research in terms of, it'll help focus what you're doing for that research. If what you're trying to do, does it actually help answer that question? Do it. If it doesn't help solve that question, don't do it. And that's pretty much it. But I think that it also could be helpful for phrasing a 1 minute talk if you haven't figured that out already.
All right, thank you, Jim. All right, Sabir.
Hello, everyone. I'm Sabir. I'm also representing Amr and Ian today, who work on the project I'm going to talk about, which is knowledge graph evaluation. So it's just some research work we've done this semester where we're given the output of an information extraction system, and we want to find inconsistencies. So in one question that's in this automatically generated output, what inconsistencies exist? And so we're given this IE output, we converted it into a knowledge graph. We created a schema for that conversion, which we can also use to query specific entity mentions and event mentions. So we first started by looking at kind of generic inconsistencies, like if a label was extracted from a sentence, or if you have two entity mentions with the same label extracted from the same sentence, do they have the same mention type? If not, maybe that's something to look at. And then we met with a domain expert who actually told us types of entities and events that in this domain, which is biology, we used over 1,000 PubMed documents. The domain expert told us that these concepts should not be equivalent, right? So then based on his output, we're mapping this kind of disjointness, and we've gotten some interesting results.
All right, thank you. Thank you. Matt is not here. We'll skip over Matt and Rudy.
The person before me never presents.
Well,
The last 2 years.
well, Matt kind of gets off because he did do the TWed last week. So
Hi everyone. I guess I make my obligatory joke saying I'm not Matt because I did that last year. So I'm going to talk about a project that I've been spending the best part of my year for. It's called DDDI, Deep Time Data Infrastructure. So the project is a collaboration between 6 nodes. We at RPI are the data science node. So Harvard does paleontology, Carnegie Institute of Science does mineralogy and petrology. There's people from Rutgers who do proteomics, and John Hopkins does thermodynamics and things like that. Okay, so what we do is we have data sets for minerals and fossils, for example, ranging from 4.5 billion years ago to now. And what we're trying to find out is how these minerals and fossils evolve. So in short, we're also trying to find out whether the evolutions seen together have influence on each other. So we're trying to find geobio coevolution as a factor. And one way we're doing this is we try to use existing data science techniques and apply it in new domains and see what we can find out simply from the data, no domain expertise required. So one thing we did was we had mineral ecosystems, which is co-occurring minerals structured as a network. So you have a network where each node is a mineral, or in a fossilized system, it's like each node is a fossil. And when these minerals or fossils co-occur with each other, they are linked in the network. So when you look at this network structure as a whole, you can get a lot of inferences from that you can't get from just looking at the minerals under a microscope or something like that. So one thing we did was we tried to cluster the network structure as a whole. So you cluster the nodes up in the network based on their connections, and you try to validate the clusters that you form with the properties that you know about the minerals. And we actually found some very interesting results. Some of them reinforce existing theories that they have, and some of them actually they look back and it's like, that actually makes sense that these belong together, and we didn't really know. So one example would be that fossils in a particular time range were of 3 ranges. So they were actually, we found that a 3rd category was not necessary. You just need broadly 2 categories. So time up. Okay,
right,
that's
thank
good. Thank you.
So far, Anirudh has the coolest word of the evening: geobio coevolution. Somebody come up with a cooler word than that.
It's not gonna be me.
Take it away, Matt.
Sure. So what I'm working on is automatic generation of scene graphs. A little bit of background. A scene graph is essentially a description of an image where the graph nodes are image objects, and edges between these nodes are relationships between the objects as they appear in the images. Scene graphs are particularly useful for a number of tasks that require some kind of information extraction from images, such as image retrieval, visual question answering, et cetera, et cetera. And there have been results showing that if you generate these scene graphs for a particular image, you can get better results for tasks like image retrieval than you can just based on like a Google image search, which uses some features of the image combined with some textual description of it. So obviously the challenge there is that we have to be able to reliably automatically generate these scene graphs. And in terms of using machine learning generative models, currently there's no better way to do that than by using a generative adversarial network setup. Essentially, a generative adversarial network setup, or GAN, relies on 2 parts. There are 2 players of a game. One player is trying to generate realistic descriptions of an image. The other player, the discriminator, is trying to tell which descriptions have been generated by this generator and which ones are from a ground truth, some data set that you have access to. And so far what I've shown is that using this setup where this generator is constantly trying to fool this discriminator, and this discriminator is trying to discern which of the captions are being, or which of the scene graphs generated are fake. I've shown that this generator actually learns to generate realistic looking triples describing objects of the image and objects of a given image and the relationships between these objects. So going forward, I have to, currently I'm just generating these triples, and right now I have to figure out how to stitch the triples together to form a cohesive graph, something that tells a more complete picture about the image. And then from there, I want to run this generator over a large collection of images and eventually generate essentially knowledge graphs from collections of images. So lots of objects with lots of relationships in between the objects, and see what we can do with that kind of information.
All right.
Thanks.
Thank you, Matt. Question. We still have geo-bio-coevolution. Those are cool.
Hi, I'm Kara Reedy. I'm a second-year student working with Dr. Hendler, and I've been working on creating a diploid genetic structure to generate neural networks and allow their structure of the networks and also the weights within the network to evolve. Diploid means that rather than only having one copy of the genetic material like you would in a normal genetic algorithm, there are actually two copies of all of the genetic material. This presents some difficulties. If you have two copies of a gene, then you need some way of determining which of those copies are you actually going to use to build your neural network or whatever it is. However, it also seems to have some advantages. The one that's been more studied is that diploid genetic algorithms seem to be a lot better at adapting to changing environments than haploid ones, and a lot of environments we're interested in aren't the same at all time points. And they also might be better at searching through very complex search spaces, but that's not been as well studied. So I have this genetic structure implemented. It can output cafe networks. It passes a whole bunch of tests, and it seems to be working pretty well. And also, while I originally created this to work with my artificial life simulation, the actual genetics code itself is not intimately tied to the simulation and could be used for other projects as well. So what I'm looking at now is different ways to try and test out this genetic structure. Hopefully I'll find some sort of advantage that it has. I didn't just waste a year of my life programming it. And also looking at integrating it with other aspects of my simulation.
All right. Thank you. Diploid genetic algorithm.
That's
might,
pretty good too.
I think that probably.
One thing that might be a possible, well,
Let's do the discussion.
yeah,
later.
you can do that.
All right.
Let me
great.
actually formulate my comment first. Actually.
Hello, everyone. My name is Rian. I'm a sixth-year PhD student working with Professor McGinnis. So today I would like to talk more about something about my thesis topic, which is related to stream reasoning. So my research question is, how do you process the streaming data in a way that you can extract the hidden information from it, and then you can provide the efficient question answering for the scenarios where the streaming data as intake into the system, right? So I approached this question and proposed the answer to model the importance of the streaming data. So that actually means if I can use the system, allow the system to identify which part of data is more important than another, and the system could be able to concentrate on the more important information, allocate more resource, storage resource or computational resource onto processing that. And currently, I model this importance of streaming data by leveraging 4 aspects. And to my best knowledge, this is the first time that someone approached modeling the importance of the streaming data. And recently, I have finished another piece of work to demonstrate the effectiveness of this model. And it turns out that this model can reduce the amount of intake of triples by 800 times, and then increase the precision at least 2 times, and also reduce the response time at least 21st times. So that's a huge improvement compared to the traditional methods in the stream reasoning applications.
All right.
Thank you.
Hi, I'm Spencer. I'm currently a senior, and I'm going to be starting the grad program here in the fall. The past couple of semesters, my research has mainly focused on semantic workflows. Probably everybody in the room at least has an idea of what they are, but I guess just for the camera, semantic workflow can be thought of as effectively a description of an in silico experiment. Just each of the individual steps that you're taking to get a particular result. It's an imperfect analogy, but you can think of it as a program just being described as data. So like any actual program, you're going to have a whole bunch of submodules that are being called out to during your workflow. And kind of the issue I'm starting to see is that a lot of those individual tasks require calling out to like some remote web service or some kind of like monolithic system that would produce the result that I'm interested in. What I'm starting to think about at this point is how we can start componentizing that. I guess like the buzzword I would use is atomized code. The idea that you should be able to pull some piece of code from the web, 50, 100 lines long, have it describe exactly what it's going to do for you, and then just be able to dynamically invoke that. There are obvious problems with that, like trust, like how do I know that those 50 to 100 lines are going to actually do what I'm assuming they will. So I'm not going to be able to do everything I want right off the bat. I guess kind of the test ground would be working with these things called safety services. Safety services are effectively a web service that just describes its input and output and exactly what it's going to append to an RDF graph that you throw at it. So I guess those would kind of be the test ground for generating annotation pipelines in this way. See if it works, I guess. That's what I got. Thank you.
Right. Thank you, Spencer. In silico experiments.
Are you going to go again, Spencer?
You got to cross your name out. Yeah, Ham's not going to come up until you cross your name out.
That's on me.
Wasn't it? I thought that was you.
That was not you. That was me. That was old.
Oh, well then, yes, you. Go ahead.
That was not me. Not you.
Go.
It's you.
Oh. Yeah, you get it. So, so the project I'm working on is also.
You need to put.
Oh. Okay. The project I'm working on is also DTDI. We're working on the coevolution of the biosphere and the mineral sphere. We can rephrase our research question as what is the origin of life? That's a big one. So basically, I want to continue to add on a little bit to his description of problem. Basically, we have two data sets. One is about fossils and one is about minerals. And between each one of the data set, all different type of minerals, they're interlinked by, they can be interlinked by the elements they share or their different chemical properties. And also fossils can be linked by their bio properties. And also between these two data sets, between these items from these two data sets, they can be interlinked, connected by the locations they share or some other links that we don't know yet. And what we're trying to do is to create different visualizations to explore the links, to visualize these links between these two different group of items and across the time, and see how they co-evolute.
That's a cool word.
Co-evolve.
Co-evolve.
No, it will not evolute. There's no such word. So basically, we're now still also we have a certain we have a set of tools that we're using. We're using core diagrams, a lot of network analysis, but we're also open to some new ideas. So I would say if anybody here got some, ideas about how to visualize to see the implications of data set like this, like multiple data set, their relationship across time. Please give us some ideas.
Well, I got some
and-
ideas. I got some
Okay.
big ideas for you.
Yeah, and that is basically my presentation today. Thank you.
Thank you. So he gets the prize for new words. Co-evolute.
Sorry, that's just
That's good. That's a pretty cool word.
That's a made up word.
Yeah, I think there's another one, co-evolve.
Co-evolve.
I like co-evolute.
Hey everybody, my name is Alex Schwartzberg. I've been working on a tool this past semester called Magellan. Fundamentally, well, Magellan does a couple things, but at its base, it essentially allows you to model a file system structure, directory files within that, subdirectories within that, as a knowledge graph, and actually do this using the neo-monk file system ontology to kind of give vocabulary for that structure. But the real magic of Magellan actually comes in by giving you an interface to define rules that you can use to augment that graph with additional attributes or additional edges. So if you're looking at a file system, you might have a directory that's, My Music / the Beatles / Abbey Road / Come Together. As a human, you can look at that and be like, oh, it's the Beatles, it's Abbey Road, Come Together, everybody knows it. But kind of how do you take that and design a system that allows you to say, oh, well, that last bit is the song title, this middle bit is the album, this is the artist. And not just say that the artist is the Beatles, but the artist is the ID that links to the graph entity, to the graph node that represents the Beatles, or the graph node that represents Abbey Road. So that's one of the things that you can do with Magellan. And then additionally, once you've done things like define new attributes or new links inside of this knowledge graph, Magellan kind of dynamically generates a faceted search interface that allows you to kind of query that graph by itself. And the last main feature that it supports is that once you've done all this knowledge enhancement, you can actually export the graph that you've generated and use it in whatever software you'd like, kind of treating Magellan almost as a sort of middleware between the raw data that you're working with and the kind of end processing result that you'd like to see. And that's more or less it in a nutshell.
And
it's all
on
ontology driven, and it's all on GitHub. And actually, you can use it right now at aeksko.github.io/Magellan. You can all read that. Comes with like 7 or 8 ontologies preloaded. It is in beta. Don't impress yourself too much if you break it, if you're trying to break it, because I'm sure you, if you try, you probably can. As the sole developer, I've been strained to do things like, input validation, things like that. I'm generally assuming that somebody using it has some kind of idea of what they're doing. But please mess around with it, find a bug, let me know, and use it.
All right.
Thank you.
And especially test his documentation.
You guys time to write documentation, John.
All right.
Making slide decks.
Hi everyone, I'm Fei Fei. This is my first year, and I'm working with actually Alex and Hao on a DARPA project. It's on the manufacturing data. We actually have 2 data sets, and last semester we basically focused on the first one, which is about, can we say that?
I think you can just, you can generally say.
Okay.
You can
So it's
generally
basically on one manufacturing aspect, and now we're moving to the second data set. The first data set, basically, we applied multiple machine learning algorithms on it, especially what I'm focused on is one new machine learning scenario, which is the label distribution. What we have is 3 failure modes, and they all add up to 1, of course. And what we want to do is, instead of doing a single label regression or multiple label classification, we want to predict 3 failure modes at once with the distributions. So it turned out to be pretty good, and the results are relatively well compared to the publications. And for the second data set, what we are doing now is do 1 regression problem and 1 classification problem. But this classification problem, we are actually doing a modified nearest neighbor search, and we're still expecting the results.
Thank you. Help yourself out. That's the most important part.
Oh, my name is Tong Tao Zhang, and I'm a student in Prestige Group. I am working on cross-media information extraction, and for the past 2 years, I answered one question is, in a cross-media situation, say you have a text document, you have images or videos, if you trust one source, can you improve the extraction or detection result on the other one? The answer is yes, but the problem is I still have a lot of things which I cannot handle under this assumption. For example, if I read an article, say a police officer is checking a hole on the door. If you want to give an image, you at most can say, okay, a police officer standing in front of the door. Maybe he has some sensor in his hand, but no one knows what he is really doing. Maybe he is looking at the hole, maybe he is looking at the lock. So my idea is, currently I want to trust both source, both the textual source and both the visual source, and try to construct knowledge graph on both sides, and then merge the knowledge graph to enrich them. Say, okay, this police officer, he is checking the hole. He is standing in front of the door, and then just construct the knowledge graph as large as possible. That is what I'm going to do for the next 18 months. Before my graduation. I hope I can do that to construct enriched multimedia knowledge graph. That's it.
Yeah. Thanks.
Hello everyone, I'm Bassam Makni, working with Professor Handler on the deep learning for noise-tolerant RDFS reasoning. So since the introduction of the semantic web back in 2001, the main uptake was achieved via the Web of Data. To date, we have 2.5 billion web pages, which contain semantic markup that adhere to the schema.org vocabulary. These semantic markups, they can either be constructed from structured data automatically, or they can be constructed from natural language texts. When we construct knowledge graphs from natural language texts, we usually use NEL tools, named entity linking tools. However, even though these tools were progressing through the years and the accuracy is improving, they are not still perfect, which induced noise in the constructed knowledge graph. This is why back in 2010, Frank Hamverman, they suggested to use they call it for the investigation of machine learning techniques for noise tolerance reasoning. 4 years later, a position paper states that the efforts to combine both tools, machine learning and semantic reasoning, are still disappointing. We claim that we can use deep learning to fill this gap. We came up with 3 approaches. The first one was sequence-to-sequence approach. Basically, a sequence-to-sequence approach is a machine translation approach. So instead of translating from one language to a language, we translate rules. So the input will be, for example, A transitive property B, B transitive property C, and the output will be A transitive property C. With this approach, we were able to learn all the RDFS rules and the subset of all rules. However, we were using a Sparkle endpoint, and that was a bottleneck. So we need to use the tool, and then we insert back the rules using Sparkle update, and that's a major bottleneck. This is why we switched it to a graph-to-sequence tool. The graph-to-sequence approach showed noise tolerance on 3 kind of experiments that we did. And finally, we switched it to graph-to-graph approach. In the graph-to-graph approach, basically, we did what we call graph summarization, RDFS summarization. So to infer from an RDFS graph, we don't need to know everything from the graph. For example, if we have like taking course as a domain student, we don't need to know all the courses that student is taking to infer that he's student. Or if a course is taken by 1,000 students, we don't need to know all the students. We just need to know that someone is taking this course, and this person is taking one course to infer that he's student. And we are achieving like 99% accuracy for this experiment. Thank you.
Hi, this is Li Fu. I'm working with Professor Heng Ji. So my research topic is called liberal information extraction. one of the main challenges for event extraction task is the current approaches heavily rely on the human annotation efforts and cannot be applied to any new event types. So we designed zero-shot transfer learning neural architecture. We model event mission and event type as a rich structure, and learn structural representation and map them into a common semantic space. So this architecture can be trained on a limited number of types, but can be applied to any new event types or any rich event ontologies without any annotation effort. Yeah.
Thank you very much.
Hi, I'm Robin. I'm fourth year PhD student working with Professor McGinnis. So my research topic now is the task of ontology matching and integration. So this task is used mainly for solve the semantic heterogeneity problems, which concentrates on finding the correlations between entities and the triples in different ontology sources. Previously, how we tackle this is mainly focusing on the character level and the token level description of the input entity or triple, which actually we ignore the higher level information, the higher level descriptive information regarding to that knowledge entity or triple. So the proposed representation learning method mainly based on deep neural nets can actually be able to capture the descriptive information, mainly the higher level correlation between the descriptive information regarding to the input entity and the triple. So by using that, particularly, we first trained it in a supervised, unsupervised manner, and then fine-tuned in a supervised way with the helpful training data. So the expected outcome can help to obtain a higher level abstract of the input source, especially with regard to the knowledge entity and the triple. So the final joint outcome can help us to better measure the similarity between the knowledge entity and the triples in this matching task. That's it. Thanks.
Thank you.
So good afternoon, everyone. My name is Jason. I'm a second year PhD student working with Professor McGinnis. So in biomedical domain, there are a lot of research paper coming up every day. So in this domain, the researchers maybe don't have enough time to go through all those papers to catch up with the latest research findings. So so for the term project in the Professor G's knowledge information extraction and discovery class, my term project is to build an intelligent machine reading system. So one of the so these systems, to establish this kind of system, some basic building blocks would be entity linking, entity typing, and relation extraction. So for this term project, I'm focusing on how to join model the entity typing and entity linking in a holistic way, so that the people, so we don't need to do these two tasks independently, and to avoid the error propagation from one step to another step. So so to solve this problem, we are looking at two aspects. One is to how to model the entity type correlation, and how to encourage the target entity links to be as coherent as possible when you are trying to link the entity mentioned to the knowledge base. So we are still doing the experiments, and we'll be hopefully get the results very soon. Thank you.
Pulse is elevated right now. But
all right, is clear. Hi, my name is Benno Lee. I'm a 6th-year PhD student with Peter Fox, and through this past year, the question that I've been trying to answer is how do you communicate change information using the semantic web? And so one of the problems first is that you need to be able to actually describe and characterize the changes involved. So I've been developing a model to sort of capture that. 2, you need to sort of capture exactly how much a data set has changed. And so leveraging the resulting graph that we have, you can calculate actually with the graph, you can calculate a flow from like an old version to a new version and then use the amount of flow between the two to actually give you an improved score or measure to determine how much a data set has changed, which is not something that you usually see involved in versioning sets. And then the third one is like, how do we communicate this sort of information to other people, right? How do we dispense and disperse this information? And one of the common things that, you know, software versioning tools and some production groups actually use is change logs, right? And so there are these text documents that are meant for people to just read and use, but that sort of limits you to basically the speed of a human reading, which is really slow compared to a computer. So why don't we just take the model that we have with its graph and then embed it into the changelog? And that way we are able to then allow web crawlers to sort of like crunch through and look at the changes of data and then help people, help inform users as to how to migrate to new data sets. 2, if someone's interested in certain specific attributes, now that a web crawler has consumed that information, we can now use like maybe Google or some search engine to start searching and looking through that data or that changelog to get you to the location where the information explains what has actually changed, right? To sort of guide you through that information. And that's essentially what I've been working on this past year. Thank you.
All right, thank you, Benno. That didn't hurt that much.
Yeah.
oh, I should cross myself off
Yes,
before I have to go again.
Hi everyone, I'm Yixin. I'm a four-year PhD in Tsinghua University Knowledge Engineer Group located in Beijing, China. And I'm now visiting a student in Hengji's lab. My research interest is I want to integrate the knowledge into the text. Why I want to do that? Because if the machine want to understand the language, natural language, it's hard to understand because there are so many ambiguous. For example, I have an apple, so the first problem is the apple really means the fruit or the company, maybe a product of the company. So my solution is to, we can regard the entities from the knowledge base as the meanings of this mentioned, this apple. So the apple will have 2 senses. One is the company and the other maybe the fruit. So I designed a model to joint learning the representation of the mentions and the entities and the words, which where each mention have multiple representations, which one of which denotes an entity. So after doing that, I evaluate the word's performance and the entity performance, and I found the entities actually greatly improve the word performance. Like we all know the word analogy reasoning task, like the man minus woman and plus the king and equals the vector of
queen, and which actually is the knowledge embedded in the entities. And after we jointly learning the representation of both words and entities, we answer this question correctly. So, so that's my.
All right. Thank you very much. Did we have any other students? I think we got everybody to talk.
I'm not going again.
You crossed off your name. Jim wants to go.
Yeah, I'm gonna go. So, I'm Jim McCusker. I work for Deborah McGinnis as a research scientist. My area of research is knowledge graphs. And so one thing about that area of research is that it's left me wondering, what is a knowledge graph? And one thing that, well, so we know what a graph is, right? It's nodes connected by edges and so forth and so on. The thing is that we're not really sure what knowledge is. And especially, so the better question is, what is knowledge, especially in comparison to other things? Like, what's knowledge? What is knowledge and what's data? What is not? What's knowledge and what's an ontology? I have a working hypothesis for the first one, and I'm curious about counterexamples. And that's data is actually facts you gather about the past. So when you measure something or you record something as being true at some point, that's data. That's something that's evidence that you've gathered about something that's already happened, or evidence that you've gathered about a prediction that you might make, like you run a simulation. Knowledge is actually what lets you make that prediction in the first place, and what you might be able to, basically the generalizations that you learn from the data when you do science. Obviously, that's a really focused operational thing, and I'm sure Edmund Gettier would tear that to shreds, and probably a lot of other philosophers I know. But I think that maybe within the context of knowledge graphs and figuring out, well, what is data when we're doing data analysis, and what's knowledge when we're trying to enhance the data? Where does the distinction lie? I think that might help.
All right. All right. Deborah, did you want to say any? Is there the senior person here? Wait, that came out wrong.
The old person in the room.
I may have to.
Great work. Keep up the good work. Oh, how many people are going to be around this summer? Okay. So most of the group.
So I wanted to mention a couple different things. So first of all, there's going to be a lot of activity this summer. In addition to people who are here this summer doing their research, we've got there's a lot of undergraduate researchers, interns associated with this lab and associated labs, affiliate labs. So there's going to be a lot of things happening throughout the summer. And there's projects going on with continuing going on with CASE, the architecture, Anna Dyson's architecture research lab, data insights, IDEA, these sorts of things. So we're going to have RPIR users group meetings throughout the summer. We may have them more frequently. We may have them the same frequency on a per monthly basis. And we will probably have TWEDs throughout the summer, not on the weekly basis like we have, and maybe an alternate schedule like a brown bag, like a lunch kind of type of thing. But we'll continue having these sorts of talks. We may have guests. We may do that sort of thing. But this is the end of the spring 2017. There's an RPIR users group meeting next Wednesday, focused on performance analysis, and then to be determined after that. So.
And I guess I have two other. Yeah. Are you done?
I'm done. Yeah.
Okay. Two other ones. There will be an updated seating chart for the summer. Jackie will end up sending it out. Won't come out for a couple of weeks.
And there'll be a great web science conference down the hill at the end of June.
Some of whom will probably, you may be asked to help.
Yes, we'll probably be looking for helpers for either free registration or discounted registration.
Yes. All right, and with that, thank you very much. Congratulations.